The mitochondrion is an organelle in eukaryotic cells that produces ATP, a molecule used by the rest of the cell to do work. ATP is produced by ATP synthase when a hydrogen gradient drives it like a motor to combine ADP, the blue spheres, into ATP. LifeBrush is a tool for painting mesoscale illustrations that come to life through agent-based simulation. The geometry tool uses implicit surface modeling, allowing the user to paint the environment like it's virtual clay. Here we're adding cristae regions to the mitochondria, which greatly increase its internal surface area and hence the rate of ATP synthesis. The example palette here contains arrangements of molecular agents that we can paint into the scene on surfaces or volumes using our generative brush. Here we're painting lipids onto the surface of the mitochondria. Now we're going to paint some of the molecules embedded in the surfaces of the mitochondria. Here we're adding junction proteins to the mouth of the cristae region, that central region. Now we're going to paint in ATP synthase and the proton pump molecules. We've edited this video to make it a little bit shorter, but the total time to paint this mitochondrion takes about 6 minutes. Real-life mitochondria are dense and chaotic. To give a sense of that busy environment, we have widget proteins. Widget proteins' function is just to fill up the visual space. But in the future, we would like to expand the number of molecular behaviors that our system implements. So far, we have ATP, ADP, and hydrogen molecular agents. We also have ATP synthase and proton pump behaviors. Our simulation are ATP synthase, ATP, ADP, hydrogen agents, and the proton pumps. These red spheres represent hydrogen or protons, and they actually represent many protons. We paint them into the cristae region where the proton gradient drives ATP synthase. Here we're adding ADP for ATP synthase to convert into ATP. And now we can start our simulation. This simulation contains more than 10,000 agents, which we can run at 90 frames a second in our agent-based framework. The simulation is interactive. We can push agents around with our hands. As you can see, the mitochondrion is dense and chaotic. Therefore, to give a sense of what's happening, we've added event trace visualizations. These trace the sequence of events that led to different interactions between molecules in our simulation. Here we're looking at an ATP synthase event, and we can see how hydrogen flowed through the ATP synthase to produce the green ATP. Viewing the face of the mitochondrial membrane, we can see the network of molecular interactions that drive ATP synthesis. In this simulation configuration, fluid pressure is going to push the hydrogen agents to a region of lower pressure. Our pathline visualization shows the path that those hydrogen agents took to get to the top. We see that there was a bias to the left. Selecting hydrogen agents at the bottom, we can see that they remained largely in the same place. Pathlines are useful for debugging. For instance, this ADP molecule should not have been able to tunnel through the collision geometry. Changing the parameters of the collision geometry fixes that bug. And create new arrangements of molecular agents by dragging them meshes from the mesh library into the exemplar. And we can set the behavior of those things. Here we're duplicating proton pumps and making an arrangement of them. Here we have an ATP synthase. we resize it using 2 hands, stretching it. Here we're adding the ATP synthase behavior. We also use the sculpting tool to create the geometry of our molecular agents. Here we're creating a proton pump, using the figure from David Goodsell's The Machinery of Life as a reference for that shape. We can also remove material with the sculpting tool. Here we're going to sketch an ATP synthase molecule. Thank you for watching.